So from the name, okay, disaccharide, di means two. So means that we need to join two glucose together. Okay, for example, or we can join one glucose and one fructose together, or one glucose with one galactose together. Okay, so in this case, as long as we have two monosaccharides, we join them together, the process is termed as condensation, because water molecule will be released at the end of the reaction. So basically, we need these two hydroxyl groups, okay, the OH group and OH group, they have to lie side by side. They have to be at the side by side, so that OH group, one OH group will donate one OH group will donate hydroxyl group, another one will donate hydrogen atom, not protons, but hydrogen atom, so that both combine together, hydroxyl group OH and H to form water molecule, and the bond that link the monosaccharide together is termed as the glycosidic bond. I will show you guys what is meant by glycosidic bonds later. So example of the disaccharides that we are going to learn here in our syllabus, we need to know how to form maltose by using two alpha glucose together. And we need to know how to form sucrose by using beta fructose and alpha glucose. And lactose is not in our syllabus, the formations, but the idea of learning how the lactose is formed basically will help us to understand how cellulose will be formed in tomorrow or later topics. Are you clear? Clear? So we need to learn how to draw a diagram to show how a maltose molecule can be formed by the process of condensation. So we need to know maltose must be glucose and must be alpha glucose with alpha glucose. Okay, so I'm going to draw it out. You can draw it in this activity 3.5, but I will draw it out in other place. Okay. So first of all, I'm going to draw two glucose molecule, but I'm going to draw skeleton versions rather than a full version, because full version is quite messy and more thing we have to put and more complicated when you look at it. Okay, so in order to form maltose, okay, question always asks you how maltose molecule can be formed. A maltose molecule can be formed. So we start to draw a glucose molecule. So now you have to learn alpha glucose. So again, we started with the ring structure. We draw two molecules of them because we need to show. Not nice. Okay, complete it. So CH2OH, H, OH, OH, H. And because it's alpha glucose, so OH below the ring. Okay, so we have to draw two of them. I should do this. Okay, never mind. CH2OH, H. You have to remember, guys, the structure, no choice. Okay, so now I label this is carbon 1, this is carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Okay, so same another molecule, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. In order to form maltose, it will be the reaction. We have to put both OH group together. Can you see that? That's OH group here and OH group. So they are side by side now. Can you see that? Okay, they are side by side. Then glycosidic bond can be formed. Okay, so what I'm going to do here is one group of the OH group, we're going to donate hydrogen atom. It doesn't matter which one. So one donate hydrogen atom, another one donate OH group. Can you see that? So how we label it? So we label it as remove as H2O. Okay, put it as remove as H2O. Okay, so now what is the complete one? So the complete molecule, you can draw it. Okay, so it's by the process of condensation. then we will be able to get a molecule of maltose. CH2OH, carbon number 6, H. So HOH. Okay, so this part, HOH, HOH. So here we have the H. Okay, draw another one. In the exam, you need to know how to draw, okay? So this H, carbon number 5, carbon number 6, CH2OH, H, OH, H, OH. So carbon number 1, carbon number 2, carbon number 3, carbon number 4, 5, and 6. Carbon number 1, 2, 3, 4, 5, and 6. So they form this glycosidic bond. Okay. So what's mean glycosidic bond? Glycosidic bonds, they are covalent bonds. Glycosidic bonds are covalent bonds. So denoted by what? Okay. So the structure of this glycosidic bond will be COC. So this, can you see that? If I rub it off here, this one is a C. And here is O. So this COC is termed as glycosidic bond. So glycosidic bond is the one that join the monomer or monosaccharide together to form, okay, either disaccharides or polysaccharide. It doesn't matter. Are you clear? As long as you can see this COC, we call it as the glycosidic bond. But for maltose, we know that we are using alpha glucose with alpha glucose, and they join at carbon 1 and carbon 4, correct or not? So therefore, this bond, we give them a specific name only for maltose. Okay, I mean at this moment, only for maltose, you need at this moment. So it's alpha 1, 4. Okay, to be more specific. So this bond here is termed as alpha 1, 4 glycosidic bond. The rest of the disaccharide, you just need to name it as glycosidic bond, full stop. That's all. Are you clear? Okay, any question? So now, why maltose is a reducing sugar? If you look at the structure here, why maltose is a reducing sugar? So how they form? So basically, can you see that this carbon number 1 already used it to form? Because we do know that if we use glucose, the carbonyl group happens at carbon number 1. Correct or not? Still remember? We have C, carbon number 1, C, linear form 1, 2, 3, 4, 5, and 6 carbon. Carbon number 1 is the one with the carbonyl group. Correct or not? So it means the reducing property must be from carbon number 1. But too bad for the first alpha glucose here, the first alpha glucose, carbon number 1 is used to form the glycosidic bonds. But the good thing here is we still have a spare one here, carbon number 1. So this carbon number 1 can actually, okay, returns to the linear form and then give the reducing property. So how it look like in the aqueous form? Okay, so you can see that you're going to have one ring structure like this. And with one linear structure. It means that we can open it back, something like this. Okay. So carbon number 1, right? So carbon number 1 can open like this. And this is the part that actually gives us the reducing property. Can you see that? Just now the H, right? The H will return here. So it means that the carbon number the glucose number 1 cannot do anything for reducing property, but glucose number 2, yes, they can go back to the linear form. Can you see that? and not joining them already, right? Can you see that? So when you go linear form, so this one will give us the reducing property. So that's why maltose is a reducing sugar. Are you clear? Okay, from these diagrams, you can see that why the maltose is a reducing sugar, because this alpha glucose number 2 actually can be turned back to linear form. But for number 1, too bad, they continue as a ring form.